In this video, I'd like to talk about how to divide complex numbers. And you can see this example problem here, this expression where you have one complex number divided by another. And we want to get an answer that is a complex number. So we want some real number plus some imaginary part. So let me rewrite that just a little bit more explicitly. We usually say something like x plus iy, where this is your real part, this is your imaginary part, and x and y are both going to be normal numbers. So we want to be able to rewrite this so that there are no i's in the denominator. And to be able to do this, we have to use a special technique, and we have to multiply by what's called the conjugate, or the complex conjugate. And the conjugate is a fairly simple idea. So conjugate. And let's say I'll start with this denominator, this 4 minus 3i. The conjugate to this is just 4 plus 3i. So you keep the real part the same, and you just change the sign of your imaginary part. Now, why do we care about this thing called the conjugate? Well, when we multiply these together, notice that we have a difference of squares. So we have the same terms, just different signs. And whenever you have that, it's a difference of squares. And so when we multiply it out, the middle terms are going to cancel out. Let me undo a few of those. So we'll do 4 times 4, 4 times 3i, so that's plus 12i. 4 times minus 3i would be minus 12i, and minus 3i times 3i would be minus 9i squared. And the tricky part here is substituting I squared. So we know what I is, square root of minus 1. And when we square this, so essentially you have the square root of minus 1 and we're squaring it. The square root and the square cancel each other. They are opposite operations, just like multiplying by 5 and then dividing by 5. You just end up with what you started with on the inside. So I squared is negative 1, which we can substitute in here. And so you get 16. These two terms cancel out. And then instead of minus 9i squared, you get minus 9 times negative 1, which just becomes plus 9. So 16 plus 9, which is 25. And so the whole point of multiplying by the conjugate is that you get a real number. Or effectively, you lose all the imaginary parts. So we're going to multiply the bottom by the conjugate. Whatever it is in the bottom, whatever complex number you're dividing by, you will multiply by the conjugate so that the denominator ends up just being some normal real number. So let's do that. Let's first rewrite it. So you have this 10 minus 20i, all divided by 4 minus 3i. And again, we're just multiplying by the conjugate. But you want to be careful because we can't just multiply the bottom by something. We got to do the same thing to the top. And that way, we're really just multiplying by 1. Something divided by itself is always 1. And when you multiply by 1, you don't actually change the value. So we already figured out the bottom. We multiplied those together, and we got 25. Now in the top, we're going to use our FOIL method, or distribution. So 10 times 4, that's 40. 10 times 3i, that's 30i. Minus 20i times 4 would be minus 80i. And lastly, minus 20i times 3i would be minus 60i squared. Now simplifying, you have 40. This becomes minus 50i. And then I squared is negative 1. So this is minus 60 times negative 1, but it just becomes plus 60. Then all over 25. And so the numbers simplify. You get 100 minus 50i over 25. And 25 is dividing into both 100 and minus 50. So 100 divided by 25 is 4. Minus 50 over 25 would be minus 2. And then the I carries along. So when we actually divide this 10 minus 20i divided by 4 minus 3i, it simplifies to this nice, clean, complex number with whole numbers. So 4 minus 2i.